Collision theory. According to the kinetic theory of matter, particles of matter are in continuous motion and constantly in collision with each other. For a reaction to occur, the particle of the reactants, atoms, molecules, or ions must touch each other through collision for bond breaking and bond formation to form the products. But not all collision will result in a reaction to form the products. According to the collision theory, only those collisions which achieve a minimum amount of energy called activation energy and with the correct orientation will result in reaction. These types of collisions are known as effective collisions. For particles that collide with energy less than the activation energy needed for reaction, or with wrong orientation, they simply bounce apart without reacting. These collisions are known as ineffective collisions. Activation energy. The meaning of activation energy can be visualized by sketching the energy profile diagrams for exothermic reaction and for endothermic reactions. The difference in energy between the energy of the reactants and the energy at the peak of the curve is the activation energy. Activation energy is the energy barrier that must be overcome by the colliding particles of the reactants so that the reaction can occur. The relationship between the frequency of collision and the activation energy with the rate of reaction. According to the collision theory, the rate of a reaction is determined by the frequency of collision and magnitude of activation energy. If the frequency of collision for a reaction is high, then the frequency of effective collision is also high. So the rate of reaction is high and vice versa. Magnitude of activation energy. The value of activation energy are different for different reactions. If the activation energy of a reaction is high, fewer number of colliding particles are able to achieve this high energy. Hence, the frequency of effective collision is low. As a result, the rate of reaction is low. Conversely, if the activation energy of a reaction is low, the rate of reaction is high. The effect of the size of a solid reactants or surface area, concentration, pressure, temperature, and catalyst on the rate of reaction can be explained using the collision theory. The effect of size of a solid reactant or surface area on the rate of reaction using collision theory. When the size of a fixed mass of a solid reactant becomes smaller, the total surface area exposed to the collision with the particles of the other reactants increases. The frequency of collision among the reacting particles at the surface of the solid reactant increases. This causes the frequency of effective collision to increase. Hence, the rate of reaction increases. The effect of concentration on the rate of reaction. When the concentration of the solution of a reactant increases, the number of particles per unit volume in this solution also increases. The frequency of collision among the reacting particles increases, hence the frequency of effective collision increases. As a result, the rate of reaction increases. The effect of temperature on the rate of reaction. An increases in temperature will cause the kinetic energy of the reacting particles to increases. The reacting particles move faster and collide more often with one another, hence the frequency of collision increases. The increase in kinetic energy causes more colliding particles to possess high energy that is enough to overcome the activation energy. The frequency of effective collision increases and consequently a higher rate of reaction. The effect of pressure of gaseous reactants on the rate of reaction. When particles of gaseous reactants are compressed to occupy a smaller volume, the pressure of the gaseous reactants increases. The number of gas particles per unit volume increases. With more gas particles per unit volume, the frequency of collision among the reacting particle increases. Hence, the frequency of effective collision increases, which results in a higher rate of the reaction. The effect of catalyst on the rate of reaction. When a positive catalyst is used in a chemical reaction, it enables the reaction to occur through an alternative path, which requires a lower activation energy. As a result, more colliding particles are able to overcome the lower activation energy. Hence, the frequency of effective collision increases, and consequently, this results in a higher rate of reaction. How can we appreciate scientists' contribution? With this knowledge, we can control the rate of reaction in many activities in our daily life.